What is wattmeter and where it is used? Let us see in details point wise so that it can be easily digest to you. Wattmeters, ultimate study notes, principles, construction and types. Exam prep. Focus on the table comparison at the end to enrich yourself. The core concept measuring power. A wattmeter is simply a combination of an ammeter and a voltmeter. Watt W is equal to V I cos phi, where V stands for voltage, requires a pressure coil, I stand for current, requires for current coil, and cos phi is the power factor. The key insight: the operating torque happens because the magnetic fluxes from the current and pressure coils integrate. Stay with me to know the goal of this lecture at last. Classification: three types of wattmeters. One, dynamometer. Electromagnet replace permanent magnet. Number two, induction relies on induced current in a disk. And third, electrostatic uses a quadrant electrometer. If the lecture provide value to you, please save the video to your playlist and share to your dear and near friend circle. 1. Dynamometer, wattmeter, anatomy. Figure shows clearly current coil CC, thick wire, less turns, in series with supply, divided in two parts. Pressure coil PC, thin wire, few turns. Across the supply with series resistance. Springs, two phosphor bronze metal spring, provide supply to moving coil and controlling torque. Damping mechanism: air friction damping is used. Thick wire has low resistance and less turns, has also low resistance. So current coil has low resistance. On the other hand, pressure coil, thick wire, has more resistance and few turns also has more resistance. 1. Dynamometer type wattmeter. Working principle. Supply given to current coil and pressure coil respectively. Current coil produces flux. Flux varies current. Similarly, pressure coil produce flux. That flux varies voltage. Fluxes interact, then deflecting torque produced. Deflecting torque varies as current multiplied by voltage. Therefore, T varies as V into I. Since I into V is equal to W, that is watt, then T varies as W. Versatile can be connected to both AC and DC supply. Serial number 2. Induction wattmeter. Anatomy. Shaded ring of copper. Crucial. Creates exactly a 90-degree angle difference between current and voltage to get deflecting force. Series coil CC. Thick wire, less torque. Parallel coil PC. Thin wire, more turns. Highly resistive. Figure shows it clear. Aluminum disc placed between electromagnets. Serial number 2. Induction wattmeter working principle. AC supply connected, current induced in aluminum discs due to induction effect. Fluxes from two coils and discs interact. Deflecting force moves disc or pointer. Deflecting torque proportional to I into V. Controlling torque is equal to spring fitted with the spindle. Damping torque is equal to eddy current damping permanent magnet near this. Restriction used as AC supply only, unlike dynamometer. To know serial number 3, electrostatic wattmeter, please stay with me at the next serial number 3, electrostatic wattmeter. Overview. Core component consists of a quadrant electrometer. When to use it, measuring very small amounts of power. When voltage is highly elevated, high voltage. When power factor is low, and measuring dielectric loss of cable on alternating voltage. Think of this as the specialist tool for edge cases. High voltage plus low power. The master cheat sheet. Wattmeter type, usability, core mechanism, and damping type. Dynamometer, both AC and DC. Core mechanism, electromagnet plus moving coil, and damping type, air damping. Induction type, AC only, induced currents in aluminum disc, damping type, AD current. Electrostatic, AC, high voltage and low power factor. Quadrant electrometer mechanism, specialized uses. No matter the type, the goal is same. Deflecting torque proportional to voltage into current. No more today. Next coming lecture is energy meter, which is very important lecture for all type of exam like competitive exam. To know, please subscribe my channel DCD Electrical Knowledge. Thank you.